we're going to be like.
We're live.
And we are back, everyone.
That's right.
Aimee and Toni, who are going to help make it make sense.
That's right. We will make it make sense.
So and, we wanted to,
let's tell the people, what is the topic for today?
We're going to tell you the topic of today is going to be about herd immunity. Because lots of people like to throw this term around, and I'm realizing people don't understand what that is. And so when we were discussing how we were going to actually launch our podcast, we were like, let's talk about herd immunity, especially now in the context of these new variants popping up. You know, a lot of people are like, are we ever going to get there? What is this elusive herd immunity? And so I'm going to let Aimee go ahead and like break it down for you guys in layman's terms, what herd immunity is. But I also would like to put a plug into, we should stop calling it herd immunity because we're not cattle.
Right. And I was going to say that too. So the term that I prefer to use is community immunity. And one of the reasons for that, well, it sounds better. Like Toni said, we are not cattle.
We are not cattle.
The other reason is that we need to start thinking of ourselves as an interconnected community of humans who are doing our best to take care of each other and to keep each other safe and healthy as much as we can. So the term community immunity is when you would have as many people in the population as you can get vaccinated so that those people are going to be protected from the virus. There are people in our population, in our community, who can't be vaccinated, like young babies right now, so kids under the age of 5. There are people that have certain conditions where their immune systems do not work properly. So we call them like immunocompromised or immunodeficient. So their immune systems just can't handle the vaccine. And then we also have individuals in our community that have like cancer or are on chemotherapeutics or other drugs that are causing their immune system to also not work properly. So they can't get vaccinated. So if all of us in the community got vaccinated who were healthy enough and old enough, have, all the right criteria to get vaccinated, we can protect the people in our community that can't get vaccinated. And we will act like shields to protect them from the virus that can cause harm and, in COVID's case, death. So that's kind of a breakdown. Does that sound like a reasonable explanation or definition?
Yeah, I think so. I mean, I think the key here is that herd immunity is not what you should, or community immunity, or population immunity.
Yeah.
But it's not what you should rely on to avoid getting vaccinated. Like that's the thing, is that a lot of folks, even before COVID, were just like, well, it's not an issue because, everybody else got vaccinated. So why do I need to do it? It's a matter of like, this idea of community immunity is specifically to center those folks who are not able to get vaccinated, that are literally medically incapable of being able to be vaccinated. There's a contraindication for whatever reason, or a contraindication meaning like there is an obstacle for them to be able to be safely vaccinated, whatever that means, right? For whatever their medical problem is.
Right. They're either too young or they have cancer, whatever it is.
Exactly. Whatever it is.
Yeah.
That's right. And so, and also that the vulnerability of people, or the things that exempt people from getting vaccinated, are different depending on the kind of vaccine that we're talking about, right? Or the kind of infection that we're talking about.
Yeah.
And so for those folks who have illnesses that keep their immune system down, those folks, we don't like to give them live vaccines, right? Because then that can actually cause an issue for those patients. And so it's very dependent on a lot of factors. I think it's important for us to talk about what those factors are exactly for you to be able to achieve community immunity, but understand that it's never that okay, let's hurry up and get to a certain percentage of people so that I don't have to get vaccinated if I can get vaccinated. Like, that's not the goal of community immunity. It's really a protective mechanism, if anything, for those folks that can't really, like babies, like Aimee said, you know, folks who have medical problems that really put them at risk of getting either the vaccine or getting sick, right? Like those are the folks that we have not, it was never intended for those who just don't want to, for whatever other reason, to get to protections. Is that, we hope that makes sense, but there are a lot of things that are components of that community immunity that I wanted to spend some time talking about. Go ahead, Aimee.
Yeah, absolutely. I think that, you know, we just need to think about this as a community of individuals that shield. We get the vaccine and we shield other people whose immune systems either aren't working or they're too young to, or, you know, to get the vaccine, like under 5 right now. We shield them from disease. So I think of community immunity as kind of like this protective force field. Those of us that can get vaccinated, that's what we're providing to other people. And like Toni mentioned, it is not a mechanism for you to like, oh, we got to 90%. I don't need to get it. That's nope. If you're able, you should get it.
That's right. That's right. Well, that's the thing. So let's talk about what are the components for community vaccination or community immunity? What does it depend on?
Well, I guess from my perspective, it would just depend on anyone who is eligible and able to get it, you know, get the vaccine to protect others. What other components are you? I know that there are a lot of nuances.
Yeah. So the things that we need to consider with regard to how do we actually achieve community immunity are things like the infection rate, whether or not, how contagious it is, you know, how many mutations are out there, how much is it circulating, and so let's talk about those things.
How infective or contagious the virus is, I think, is probably one of the more important components.
That's right.
So like, as an example, measles, that's a virus that's like spreads like wildfire. It is supremely contagious. So in order for your population to be protected from measles, you need like, I think it's about 95% of the community to have measles vaccination to provide that shield. That's because it's so contagious. There are some viruses or pathogens that are less contagious, and because of that, because it doesn't spread as quickly or effectively, you can lower. So there's other viruses that spread less quickly. The herd immunity rate might be closer to like 85%. So I think that how contagious, how quickly, and how effectively it spreads, that is definitely number one. Now, I know also right now for the COVID vaccines for SARS-CoV-2, the virus that causes COVID-19, we as a population in the United States, I think, not looking at different subpopulations, but overall, I think we're around like 70%, which for something so supremely contagious, nearing measles, that is not going to cut it.
That's right. And then the other thing is that while it might be a global 70% or national 70%, the pockets of communities are at 30, right? There are pockets of communities that are at nowhere close to achieving that. And that is not going to help the entire nation actually get to the percentage that we need in order for us to form this community shield.
Right.
So the infection rate and how contagious the virus is super important in being able to achieve it. And I think one of the reasons we wanted to bring this up is because early on in the pandemic, a lot of the media came out and was just like, we got the vaccine, we just have to achieve herd immunity and we're going to be good. You know, we're going to be good, we're going to be out, you know, and I was like, no, this is going to take quite a bit of time to achieve that. And so I think one of the things that Aimee and I wanted to talk about was the fact that like, we shouldn't at this point really use community immunity as an anchor to get out of this yet, because there's just so many variables at the moment that we're still trying to wrap our heads around. I think the goal for me as a physician, I think for Aimee as a scientist, is just, we want you not to die. that is the movement. We don't want you to die. We cannot say that you are not going to get infected at this point, right? We have 2 years of data that demonstrates that this thing is able to be transmitted, whether you're symptomatic, asymptomatic, or not. But what we do know is that if you have this protection, you can avoid death and major disability with long COVID. And that's what the focus is right now. And we're gonna, hopefully, it's gonna take some years for us to achieve this community immunity that we're talking about, not to mention the global implications with vaccine inequity that's happening all over the world. And so we're not gonna get into that, but what's important to understand is that for your community of folks, if you're in a family, if you've got pockets of people who are not immunized or haven't gotten who haven't gotten naturally infected, which we also found, I dug into this, even if you're naturally infected for some reason, and this happens with some viruses, and that vaccination actually confers more protection than actually getting the natural infection of COVID, which is one of the benefits of getting the vaccine. You would think that for other illnesses, if you get it, you know, like chickenpox, for example, you get chickenpox, you don't need to get vaccinated because it's the same story. That's not the way it works for COVID, because that's just the way that this virus is. It's just one that when it infects you naturally, you have some protection, but you still can get infected again. And we know people who have gone through that.
You want to dig into that for a minute? Because I have some
Let's
ideas.
Go dig, please. No, you have a really good way of explaining this.
So this is something that I think I get asked, by quite a few people. My infection, some people call it natural infection. I like to call it infection out in the wild.
Okay, make it wild. I'm gonna make it wild.
Like at the grocery store, out in the wild. So people who acquire COVID, out in the wild, out walking around doing their own thing. We don't know how much virus, we don't know if a mild illness or asymptomatic or moderate or severe, we don't know that any of those types of infections, if they confer different levels of protection. So that's something that, I think we're still working on. What we do know, though, is that when you get the vaccine, you're getting a fairly decent dose. Well, you're getting message right now that makes protein, you get all this spike protein made. You're getting a consistent and decent dose that we know provides like this pretty vigorous immune response. So anytime you get that, we know it's like, wow, your immune system's kind of going crazy and making like a pretty good response. When you get the form of the virus, out in the wild, we don't know how vigorous your immune system is actually responding to that virus. So I think, there's just a lot that we need to learn to kind of pick apart, is asymptomatic, mild, moderate, severe, do they confer different levels of protection? Right now, we don't know. But what we do know is studying patients that have had COVID, their immunity tends to decline more quickly than people that have gotten the vaccine. That's something that we do know right now. So we know that whatever the vaccine provides a very potent trigger of a very good immune response, which sounds kind of, why wouldn't the virus do that? Well, guess what? We know that viruses, their job is to survive at all costs.
That's right.
And to mutate at all costs.
That's right.
So the best way to be a virus is to not alert the system.
That's right.
Don't trip the house alarm.
That's right. That's right.
Kind of like under the radar. So that's right. that's kind of, I think what we're seeing here is that it's getting in the immune system for whatever reason. It's not tripping the house alarm. You're not getting this vigorous immune response, and that you're not going to have like as great of protection. Now, one thing I can say, not that we would recommend that you get infected with COVID if you haven't, but people that have had COVID and then get vaccinated, they have like really good immune response. Like it's kind of like you're layering on, all this, immunity. So I don't recommend that,
No, we don't want you to do that.
We don't want you to do that.
It does actually, that's actually, goes into one of the questions that we get often. So when people are like, well, I got COVID already, I don't need the vaccine. Actually,
you do.
It doesn't protect you from getting it again.
Right.
And if you get the vaccine, you're protecting yourself even more. I mean, if there's anything, you're the person who should definitely get the vaccine, because you might not need, your immunity might actually persist. We still are early in the data mining for this infection. But I think that what Aimee and I, when we were having our Facebook message back and forth, we were like, God, this virus is smart. Like it's just a smart virus, right? It's kind of, the same reasons. I don't want to get it too complicated, but what I try to tell some folks is that, like, one of the reasons we don't have an HIV vaccine, because that virus is super smart. And it's just really difficult for you to think of how are you going to vaccinate someone for a virus that kind of can hang out in your body for 10 years before it decides to rear its ugly head. I
think that SARS-CoV-2, the virus that causes COVID-19, is just really good at kind of under the radar, not triggering the alarm system as much as it should.
Good burglar.
Yeah, it is. For whatever reason, it is really good at stealing your house.
Yes, right. That's right. It gets under it. So hopefully that understanding that is important for you to understand why we're talking about community immunity and why it's important. But we are here to tell you that we are far from achieving community immunity in COVID-19 at the moment.
Yeah.
It's not the solve at the moment. And so we really just want to talk about, making sure that you're protecting yourself and your family and the people that you love as much as possible. And we want you to feel good about it. We want you to feel like you did a good thing and that you're not actually hurting yourself or your community, but this is actually a good thing.
Yeah. I get a question along with like the natural infection and herd immunity kind of thing. One question that I think people have for me a lot is, well, if I've been infected, why do I need a vaccine? Why am I not considered part of the community immunity, part of the herd?
That's right.
And I think that,
I get that a lot too.
So I answer this question a lot, and I'll say, well, you know what, they absolutely do have a low level of protection. But what we know is that it goes down more quickly, and we don't think it lasts as long. And the only way that we know for sure that you're going to be protected or have some level of protection is if we get that shot into your arm. Because I've also encountered people that will ask me that question. And they're like, I said, oh, well, did you get a PCR test? And sometimes they're like, no, but I had a really bad cold. I'm like, I mean, it might have been COVID, but it also might not have been, because other viruses still exist.
That's right.
So that for me, I think when we get that vaccine, we know that you got to taste a SARS-CoV-2. Right.
And I mean, even if you did get a PCR and you were COVID positive, what we're saying is that the natural immunity, we know that the natural immune response is not as robust. It just isn't. And it doesn't protect you from getting it again. And I know people who have gotten COVID, like a lot of physicians who are working in COVID, who got COVID and then got it again. And then got it. And then when they got the vaccine, they actually reacted because the fact that they had like a strong reaction to the vaccine shows that the immune response actually reacted to the immune response.
Showing that, they had responded to it before. So they had definitely seen it. So that was a good thing. Your immune system was like, I see you again.
I see you. Burglar.
Exactly. You're not getting in this time.
We got you this time. Okay. We're not having it this time. So let's go. We have a bunch of questions here that we have collected from patients, from friends and family who are still skeptical about all of this stuff. And we wanted to dig in a little bit. So one of the first questions is, how can we achieve herd immunity if there are constantly new variants emerging?
This is a good question. Let me just start out by saying, if everyone in the whole world that got vaccinated, including all the pockets, that we're not reaching, which is it's the fault of a lot of, health systems, we could eliminate any future mutations. But of course, that's, the pipe dream. Can you say the question again?
Yeah. So how can we achieve, I'm going to say, community immunity?
Yes.
I'm going to swap out herd,
swapping it out
as much as I can, so that we can get into the habit of not staying herd.
I like it.
So can we achieve community immunity if there are constantly new variants emerging?
Yeah. So do you want me to try this one first?
Yeah, go for it.
Yeah. So I think that no matter how much the new variant changes, there's still going to be remnants of the old variant that we will likely have a little bit of immunity to. So like every time SARS-CoV-2, which has all these spikes, the spike protein on the surface, it's not like it's changing out the spike completely. It's not going from like a red spike to a blue spike to a green spike to a yellow spike. It might go from like a red spike to like kind of orange. And then maybe from orange to like a yellowy orange. And, and I'm using colors, to kind of allow you to understand, changes, but there are going to be some similarities that you're going to have some immune memory to if you were vaccinated. Now, of course, there are going to be new pieces that you're going to need to respond to and build memory to. But I think that the more people that are vaccinated against these early variants, the more protection we'll have in kind of, like Toni said earlier, fighting it off to the point where you don't have severe disease and you don't die. You might get infected and you might feel a little bit sick or have some moderate illness if you're a normally healthy person, but you're not going to have severe illness or die if you get vaccinated. So I think that it is tricky, but I do think the more people that get vaccinated, again, across the globe, ideal. And there are problems with that, but I think the closer we would get to that.
Yeah.
That's my take on the science of it.
Right. I think the other part of it is that we're going to constantly have new variants emerging the longer that this virus circulates, because that's what they're trying to do. They're trying to survive. And so in the ideal terms, right? So like if we were able to put everything in our cute little experiment box, where we like to do things in science, right? Where we can control the environment, and we have the one that, is a controlled environment with no intervention, and then the one with an intervention, and then we can kind of compare and contrast. What we would love to have been able to accomplish is that the vaccine rolls out, everybody gets it.
Yes.
Bam, bam, thank you, ma'am, we're done, right? Because now if we were able to do that, then we wouldn't have the circulation of the virus, so that it could get to do the thing that it does, which is mutate. And one of the things that was a good example of this is that you see the Delta variant emerging from, overseas. And then it also shows up in America with somebody who's never had contact with anybody overseas. Right. And so you're like, how did it get there? Well, because it was on that's the trajectory of mutation for that virus, like that, no matter what environment, it was going to become that Delta virus, whether, whether it was in Europe or it was going to be in the US, like it was just going to happen. And that's what people don't understand, is that they're thinking that, oh, well, the virus came from Europe, or the virus came from Africa, or the virus came, no, it was circulating, and it's on its way no matter what. It was within its pattern.
Yeah, exactly.
That mutation. Is that
Should we dig into that for a second?
Let's dig.
Is something that I have been talking to anyone who would listen to me about this for like forever. So I'm going to use a science term though, but then I'll unpack it.
Let's do it.
So we call in virology, which I've also taught virology, it's called convergent evolution.
Yeah, sounds fancy.
I know, it is very fancy. It's super fancy. I feel
like I need a martini to listen to this because it's so fancy.
Yeah, hang on.
Hold on. Let me get a fancy drink.
So what that means is that you have Delta here in the United States, and you have Delta over here in Africa, and you have Delta in Europe, and same strain. Okay. Let's pretend nobody's traveling. No one's traveling. Let's just make it up. Nobody's traveling. Right. I can find mutations here in the United States of Delta that look the same, mutations. So changes, differences that look the same as the Delta that's in Africa. They're evolving, mutating, changing, trying to survive. Same thing in Europe. Nobody moved.
That's right.
Nobody traveled. It's because the virus, its job is to mutate and survive. So it takes on all these changes. It doesn't matter where it is, because people would say, just like Toni mentioned, oh, we just saw that in Africa. Oh, wait, now it's in New Jersey and blah, blah, blah. And it's like, yeah, it's not because like that same person magically traveled the globe. Okay.
Right. Or that they got in contact with somebody that came from there.
No, it's because viruses mutate and evolve, and they will do anything to make their lives better and easier to infect us. And it just happened to be that those couple changes in different parts of the world happened at the same time, because it makes them better at being a virus.
That's it. That's right. And so the way to achieve, so the answer to the question is, we cannot achieve community immunity as long as there are new variants, because the fact that we have new variants means that we haven't gotten to a threshold yet where everybody has gotten immunized, whether naturally.
You might have a little bit of memory. You might have a little bit of immune response, some similarity, but it's going to be, it's not going to be as good.
Right.
For sure.
That's right. And so that's why we love this question, because it's like, let's stop talking about community immunity until we can get everybody vaccinated, right? If we still have folks that don't want to get vaccinated, we're going to continue to, like, these new variants aren't going anywhere. As long as we stay at the rates that we're at, we're going to get another surge and another surge and another surge. It's just going to happen. It's going to continue to happen.
Yeah, this is going to keep happening.
That's right. The next question we have is, why do my kids need to be vaccinated if we, the parents and other adults that they are in contact with, like teachers, for example, are around them who have been vaccinated?
Mm-hmm. Well, you as the pediatrician.
Yeah, I can answer. Well, I mean, the whole thing is that, kids are, I told Aimee this in the beginning of when we had started talking about this, but when they had reopened the schools, I'm by a school, I live by a school, and I walk my dog by the school, by the playground. And this was like even before they had reopened, I think at a point where vaccines weren't even out. And the kids, the masks were like this, like on their face. Yeah. They were like licking each other and hugging each other. Like it had been a long time since they had just opened. Kids, there's no way to stop kids from like touching each other and like slobbering all over each other. That's the reason why there are childhood vaccinations in the first place, right? Because like kids are just little, I love them, but they're little petri dishes. God bless them. They are little petri dishes. And they can just transmit all kinds of stuff. And so right now, to be honest with you, the parents being vaccinated do provide that shield that Aimee was talking about around the children who are not eligible to get vaccinated. But the ones that are eligible to get vaccinated, the ones that are 5 and older, if they can be vaccinated, they should be vaccinated, because if you have a child that's less than 5, you're actually becoming the shield for that child. And so that's why it's important, because just because you as the parent do not have you as the parent have gotten vaccinated, again, you can still get infected and transmit it, right? Like, of course, the rate is way, way, way lower than if you hadn't been vaccinated, but it's not zero. It's absolutely not zero.
Well, the other thing,
go ahead. No, and I just want to say, since it's not zero, do you want to play that Russian roulette? Do you want to take that chance to pass it on to your child? And yes, okay, fine. The other conversation is that, well, in children it's mild, but as a pediatrician, you have to understand that we don't like sick, dying children. Like, we don't like that. No. That's not something that we enjoy at all. No. And just for comparison's sake, the flu, which is a killer, right? And why we ask everybody to get a flu shot. Yeah. In 2020, only one child died. Not only, it's still terrible that one child died of the flu, but over 300 children died of COVID. Right. Like, this went around pediatric circles. Like, pediatricians were like, yeah. Kids, like, that is just something that's not okay. That is not okay. Children, we do not like children dying of preventable illness. It's not something that we like. And so the reason we want to vaccinate you, we don't want you to take the chance that your child is the child that actually ends up dying or being severely debilitated from COVID. Like, there's no reason for that. Like, we can prevent it by giving them the vaccine. So that's why, if you are vaccinated as a parent, if your child is eligible for the vaccine, we encourage you to go ahead and vaccinate them, because it's safe. It's safe. And but the last thing I want to say, that when I was reading up on this to prepare for this podcast, it was like, you know, the fact is that when we're looking for vaccines for children, they're tested on adults anyway. Right. And the amount of adults that have taken the vaccine at this point, the data profile, the safety profile, is something that we would never, ever have had for any other vaccine. Like, the amount of safety data that we have before it even touches a child is more than we've ever had for any other vaccine. Is that true? Did I make that up, or is that true?
Yeah, no, I agree. I'm going to add to your answer in the sense that, let's say that the parents and the teachers and maybe the grandparents or whoever the kid comes in contact with is vaccinated. Let's just say everybody that they surround themselves with is vaccinated, except other kids, right? You cannot guarantee, unless you keep your kid in a bubble and they're at home and then they walk to school in a bubble and they, go to the school. There are people out there in the wild that might have COVID, that walked, in the area where you and your kids are walking, that coughed up a lung, like, let's say a minute or two ago, right? You don't know. Thank God we can't see what's in the air.
Right? Oh my God.
Because if we did,
never leave the house.
I guarantee you I would not ever.
I wouldn't leave the house. I would not.
Well, I would not be breathing. I would be like, no thanks. Hard pass. Right? So, like, I guess my point is, like, yes, everyone that they know or surround themselves with might be vaccinated and protecting them, but you don't know, like, you walk the dog, and you should, right? You should, go outside and walk the dog, but maybe you're going to come upon a pocket of, freshly coughed air that you didn't see the person. Do you know what I'm saying? Do you understand what I'm saying?
I don't. You just see a cloud of germs.
Well, I mean, I know wind exists. Yes, I get that. If it's a super windy day, I don't know. Is it going to blow you a pocket of freshly coughed air? Maybe. My point is, we don't see everything.
Welcome to the conversations of Toni and Aimee, by the way, everyone. This is how we like process information. Clouds of virus pockets that have been freshly coughed up.
Freshly coughed.
You just walked right in it. Ew. Oh man.
So I'm just adding, like, the unknown to that.
That's right. That's absolutely right.
Keeping your kid as protected as you can.
Right.
But there are unknowns. Like, often whenever we get, pre-COVID without masks and all that, we pick up colds and stuff, and I'd be like, I don't know where I got it. I didn't know anyone who has a cold. Well, that's because you walked through a pocket of air.
Or you touched a doorknob and you touched your face. So let me just give you an example of how we're not thinking about things, right? So I was, going to work one day, and there was a healthcare worker who got onto I'm assuming a healthcare worker, this person was in scrubs. They were in a healthcare clinic, right? So well, they were in scrubs, but they were also in a healthcare clinic, right? Like they were going to another floor or whatever. And this human being had the mask on, right? And pulled out, like, and this was at the time, like, everybody's sanitizing. We didn't know. This was when this was during the time, remember, we were like spraying our Amazon packages.
Yeah.
Right. So like, we're all like paranoid about everything, right? And so this human being gets onto the elevator and takes out a pack of gum.
No.
Yes. Wait. Hits the button for the floor, and then takes the gum and puts it in their mouth.
Had to lift the mask.
Lifting the mask was one thing, but like, you just touched the elevator buttons,
right? Which could have been freshly coughed on. And then touched gum and put it in their mouth. I was like, no. Yeah.
I was like, oh no. And so I'm saying that, like,
we're
not conscious of, we're not spraying. I mean, as paranoid as I can be, I have like sanitizer everywhere, and I'm always like that. There are moments when you touch the desk and then you scratch your eyeball, like you just do it. And so this is how things get carried around, and somebody's going to say, but COVID isn't spread that way or whatever. We understand it's aerosolized. We get that. But what our point is that, that's how you're able to get other things. You never know where you're at. There's a lot of unknowns. You can't control every single piece of everything that you're doing.
You can't control every piece. And
you can't control it.
Yeah. With that, going back to that same fictitious kid, unless you put like a, space helmet on wherever you go.
That's right. It's impossible. And so again, the goal is not to not get infected necessarily. It's not to be severely debilitated, ill, die. That's the goal, right? We can't say you're not going to get it. Because there's just too much. We're doing too much.
You can try. You can try, right?
You can try. We can.
I know a lot of people who have not yet had it.
Yeah, I mean, I consider myself incredibly lucky. But I mean, we all have people. I have people in my family who have passed away, unfortunately, from it. I have had patients who have died from it. I have had patients who've gotten sick from it and have debilitating illness after. And so I think remember that the goal is that we want you to be here. We want you to be healthy. We want you to have good quality of life. It's not about avoiding infection necessarily. It's the consequence of the infection at this point that we're trying to help you avoid. And so whoever can be eligible to get vaccinated, that's the long answer to why your kids should be vaccinated if they're eligible, even though their parents are vaccinated.
At this point, I'm kind of thinking that each of our podcast episodes may be answering one question.
Maybe we could do that,
because we kind of like, we dig in quite.
We dig in. We get excited.
I mean, I used some big terminology, but I unpacked it.
You did. I think it was clear, and I'm sure whoever's listening to this, if they're confused, they can write a little comment and say that, yeah, Aimee, that was way too bougie of you. I had to pull out some martinis to understand exactly what you were talking about.
Exactly.
So we're going to make sure that we keep ourselves honest here. All right, let's go through a couple more. I think we've answered some of them. So if we've answered some of it in the commentary that we've made, we'll keep it moving. But I wanted to try to see if we could hit a lot of these. So if you got it, you don't need the vaccine. Doesn't natural infection lead to community immunity? I think we answered that.
Kind of did, yeah.
You can always tell us if you don't think so, but again, that the natural infection is not as potent of an immune response as getting the vaccine, which is a controlled amount of dose that we know you're going to, that we know you're going to respond to. Mm-hmm. Is community immunity a myth, or can it be achieved?
It definitely, I think, in the context of just pathogens in general, not COVID or measles or chickenpox or whatever, I think that yes, we can, but that takes a lot. It takes a lot. There's a lot that goes into that. Like, everybody in the world who should be vaccinated. That also means that we'd have to get vaccines to everybody who wants one, which we know is not happening right now. That would also mean that variants would have to kind of stop occurring or kind of slow down or not be, we don't know what the mutations will look like. Anytime a mutation pops up, will it cause less severe disease or more severe disease? Viruses don't care. They just care if they survive. Doesn't matter to them if they burn the house down or not.
They don't care,
right?
Those viruses.
So I would say in general, just or in generic terms, yes, you can, but there are a lot of pieces that go into it. What would you add to that?
No, I don't think. I think that you said it all there. I think that I'm trying to remember the dates. I don't have them off the top of my head. I have them somewhere. But I like to talk about the smallpox vaccine.
Oh, okay.
And how long, I mean, it took, that's the only one that we've actually been able to eliminate. And it took decades to achieve herd immunity. It took decades. And it was a concerted effort, right? It was a concerted effort to get everybody in the world vaccinated, right? And it took decades. So really important to understand, to achieve community immunity and to actually eliminate it. So the thing is that smallpox shows us we can do it. We can do it, but it takes an enormous amount of effort in order for us to get there.
I agree. I mean, it's definitely achievable. Also, like, look at polio, again, I think we got rid of it. And then I feel like recently I've heard that we haven't seen the last of it, but
it's in 2 countries. This is the last reading that I had. It still exists in 2 countries. We were very close to eliminate. We were so close. And then it was just, it broke down in a couple of countries.
Yeah. And that's the problem. If you have like the weakest link, if one chain of the entire, chain breaks, gone.
That's right. Okay. So what percentage of the US population would need to be vaccinated in order to reach community immunity?
For COVID? Mm-hmm. Yeah, I think we don't know the answer to that right now, but like I can give some examples. So for measles, I think the rate of infection, it's pretty high. So I think that, do we want to talk about the R naught? Or is that something no, okay. No, forget it.
It's too confusing.
Okay. Yeah. So for numbers, when people get infected, we have like this infection rate, and we have a fancy term that I'm not allowed to use. That
just insert fancy term here.
We have a very fancy term so it means that for every one individual who's infected, the likelihood of them, like how many people they would likely infect, right? So for measles, I believe that for every individual infected, it's 12 to 15 individuals they will likely infect. So because measles is so incredibly contagious, we have to have our population, our community, vaccinated between I think it's 95 and 97%. You can type in the comments if I'm wrong. It may be higher, it might be, but anyways, the point
is a lot of people need to be
vaccinated. A lot of people need to be vaccinated because that is so contagious, so infective. Now for COVID, it's not as contagious as measles, but it's close.
It's getting there with these variants. I'll tell you that.
Right. Omicron definitely upped the game. Right.
That's right.
I mean, Omicron was like,
hold my beer, Delta.
Hold my beer, Delta. Check this out.
Okay. Check out what I got.
I'm gonna spread like wildfire. You thought you were gonna be like, I'm better.
You think you know infectivity? Let me tell you.
Exactly. So because of that, Omicron, for this variant, it would probably be close to that percentage. It's probably not as high as 95%, but I don't think we are ready to say what it would be. I mean, if we had to give a guess, I would say, hey, let's go for over 90%.
Yeah.
And right now we know as a whole in the United States, not looking at pockets, we're at 70. But if you look at some pockets, they're at like 30%.
Yeah, that's right.
So is it achievable? Yes. Do we know what the number is? No, but it's got to be quite high because this is very contagious.
That's right. And then a follow-up to that was, how do boosters contribute to that number?
How do boosters contribute?
Yeah, okay, so community immunity.
Yeah. So first of all, I would like to start using the words dose.
We're just going to tear down all of the terminology that's been going around because we don't like it.
Yeah.
We don't like it.
So booster, I think for a lot of us often means like the finale of vaccination, like the end game. I do not believe that we are there. So what I would like to say is, instead of booster, I have had dose 1, dose 2, and also my 3rd dose.
Yes, that's right.
I am now going to be probably awaiting my 4th dose. And then maybe after that, I might have a 5th. But I am not using the term booster because to me, that's like, ooh, let's just have like a little finale.
Yeah. And I think that it actually gave people so much hope that that was going to be it.
Yes.
When it was like, oh, it's the way that it was rolled out, it was like, oh, we require a third dose, which we're going to call the booster. And everybody's like, all right, it's a booster. Done. And then we're good to go. And then now we're getting data that it's like, maybe perhaps there might be a 4th dose on the horizon. You know what I mean? And that's frustrating. That's exasperating for people because we're like, everybody wants this to be over. Right. Everybody's tired of getting shot up. Know?
And we don't. And so that's the reason why I would say 3rd dose for now. I wouldn't say booster. I'm going to go by dose number. But until we did that 3rd dose, it keeps your immune system going a little longer. Of course you have memory, but the thing memory cells, what we're looking at is antibody. That's the protein in our blood that surrounds the virus and, causes it to kind of be tagged for destruction by other immune cells, right? So that's what we're looking for. And we see antibody kind of declines. Now with the 3rd dose, it stays up a little bit longer and then kind of starts to go. And that's where we're going to figure out, okay, well, when is it at a point where it's no longer safe and we have to get that 4th dose? So that's my reasoning for using, I think, dose over booster. Because to me, and I think to most of the population, booster is like finale, like we're done. But no,
agreed.
But it's not true. That's not it. So I don't think we answered the question though.
No, but the question is, how does that extra dose contribute to community immunity?
Well, yeah. So I think for each individual, it's just going to increase their the amount of antibody or the amount of protein, the amount of the immune response that's happening in their own body. And I think that so that's the individual. As far as the community, I think we're just going to keep those levels of immune response higher in each individual as a collective. And that's going to, provide more of that shield and protection. So I know that I look at, if some people have only had 1 dose, I know their protection now, if that was a year ago, their protection is pretty much almost zero, although not completely, because they have some memory for sure. If they have 2 doses, they're a little better. If they have 3, I know they're doing the best. I even personally know a couple people that have had a 4th, actually. These are people with autoimmune diseases. So their immune system is a little bit impaired. So they have that 4th dose because they didn't have as vigorous of a response as people like me who are healthy with 3. So they're getting a 4th just to enhance it even a little bit more. Mm-hmm. So yeah, I think that those can contribute. Absolutely.
Yeah. So they do contribute by making sure that your immune response is at a level where they can respond. Yeah, that's the way that it contributes.
So can I give an analogy for that?
Sure.
Okay, so let's pretend like I'm training for a marathon. Which I have done, but I don't see that in my future, but let's pretend I'm training for a marathon. So I'm, you can think of your first dose as like when you're getting out there, you're starting to run, you're doing 5 miles, 10 miles, 12 miles, you're feeling good, right? Your second dose maybe is kind of like, I'm getting good at this running thing. I'm going to run on average like 10 miles, 15 miles. Maybe I'll do a 17 mile, I'm getting pretty good at this. My endurance is up there, right? Okay, for third dose, I can run that marathon. I'm ready. I'm gonna do it, and I'm not gonna feel tired. I'm not gonna die at the end. I'm not gonna lay down for hours. Like, I'm gonna go have something to eat and regenerate, but reinvigorate myself. But I'm feeling okay. Now let's pretend that I don't run again for like a year. I take a whole year off. I don't run. Let's say I don't even work out. If I go and try to run that marathon,
you're going to die.
I'm going to die. I am not ready. I have not trained. My muscles have no memory. I am feeling like crap, right?
Yeah, right.
So I like to think of the vaccines are training our immune system to be ready to defend us against pathogen. Just like if you're a runner and you're training for a marathon, you're getting your whole body, your muscles, your cardio system, everything ready to run. Mm-hmm. You don't want to take a year off. You're going to get that 3rd dose and keep it up there. You're going to get that 4th dose. You're going to keep it up. You're going to keep doing whatever you need to do to be ready.
That's right. I like that. That's really compelling. I like that.
I had a couple of students work on that one with me.
Yeah, well, it's very good. It's very good. I like it because I think it's true. I think that, everybody's kind of like at the place where it's like, how, what is the cumulative effect of all of these doses? You know what I mean? And it's just, we're trying to keep ourselves in the game, right? To live as long as we're supposed to live and to not have any like,
I'm going to run that marathon and I'm going to live.
That's right. That's right. I like that. Okay. So how much of a population is enough to determine community immunity? I don't think that there's a number of the population to determine. I think it's something that what we're trying to understand is how much of whatever the population, doesn't matter the number, is immune to be able to confer this shield for those who cannot be actually immunized. So that it's not necessarily a population number, like this community has 1,000 people and this community has 10,000 people. It's just those folks in those populations need to get to a certain level of immunity in order to have the protective effect. Does that make sense? What I said? Also, do we include those who contract the virus naturally, or is it more for the vaccinated when we're talking about community immunity?
Yeah. So from like let's say just boring science and data, we're only including the people that have been vaccinated, because again, we know that they got a decent dose of the pathogen, or at least something that would make the protein of the pathogen, right? And that we know their immune system, based on all the science data, has provided a vigorous immune response. It's just so variable when you get it out naturally in the wild.
Right.
So from like just a sheer science and data perspective, we're looking at vaccination rate. We're not looking at, natural infection. It doesn't mean that those people don't have a little bit of antibody or some immune response. It's just that we know that it wanes pretty quickly.
That's right. So just to add to that, if when people got COVID and survived it, never got COVID again, then we would include them as part of the community immunity pool.
Right.
And we wouldn't even be talking about multiple doses of vaccine. Right. We would just, then it would be a way for us to include them in the population of folks that have population immunity, because we know you can't, once you get it, you can't get it again. The game completely changed when folks who have had COVID said they had it more than once. Yeah. Then we can't rely on natural infection to believe that because you have had it, you are protected. Right. We can't do that.
Again, that goes back to the fact that SARS-CoV-2, the virus that causes COVID-19, seems to not, when it enters our body out, natural infection out in the wild, it doesn't seem to trigger the same type of alarm that the vaccine does. It's stealth. It's that burglar. It's coming, it's sneaking in through the window. It's coming in to steal your stuff. For whatever reason, it just doesn't set the alarm in the same way.
That's right.
All right. I got one more. Can do one more, and then I got to head out with my son.
Okay. No problem. Let's see. I think I want to talk about,
you pick chef's choice.
So this is kind of a mishmash of the last few ones, where it's basically, are these vaccines even working? When originally it was suggested from the CDC, in order to attain community immunity, we needed a 70 to 90% vaccine rate. Mm-hmm. And you have countries like Singapore, Portugal, Canada, Italy, and France that have over 70%, and some with 90% vaccination rates. Why haven't they attained community immunity? And then this is all part of the same question. And then there is an epidemiologist named Raiwat Dionanadin. I'm sorry if I mispronounced that. Dionanadin, who says that the humoral response to COVID vaccine seems to wane very quickly, and that he's not sure that with the booster we would offer a longer response. So are these vaccines actually working, and to what extent?
Yeah, that's a lot of question.
it's all kind of about the same thing. It's like, does it work? Yeah.
Let me unpack one part. Okay. So as far as the effectiveness, yes, people are not getting severe disease and they're not dying. Unless, of course, they have like an underlying condition like Colin Powell, who had cancer, right? Mm-hmm. I mean, there are a lot of people that have been vaccinated that do die, but it's typically from having some other underlying condition like immunodeficiency or autoimmunity or cancer. So that's, I think, kind of one piece. So yes, we are not getting severe illness or dying. That's huge. Not dying is, I think, really important.
That's a very important part.
Seems like number one.
That's number one.
The other piece I would unpack about that is when you mentioned a couple of other countries. We're not all using the same types of vaccines. We are using here the mRNA vaccines, right? The Pfizer and Moderna. Those things are off the chart amazing. Like, I mean, we could have an entire podcast about what a marvel those are. Like, as an immunologist, I am like in just
you just geek out.
These are like the superheroes of the vaccines. Like, I have never seen something like this. It is just like, I am truly in awe. Not every country has that. So like you mentioned Singapore, they don't have the same. Yeah, sure, they might have a higher vaccination rate, but unfortunately, I think a lot of, so the vaccines they're using are not as effective. We saw Moderna and Pfizer like 95 to 98% effective. I have never seen that before. To me, that seemed like that cannot be real. Of course,
I remember your post on Facebook when you were like, "Oh my God, it's 95% off."
I mean, like, unbelievable. I had to read all about it. So I was like, oh my God, this is actually real, right? But there are other vaccines that are being used in other countries that I think provide protection. Because again, not dying, number one.
That's right.
Number one is not dying.
That's right.
But they're just not at that 90-95%. They're much lower, which
that's right.
You know what? Better than zero, better than dying. But I think you have to take into account which vaccines are being used in different countries, because you can have, let's say you have 100% of, or 99% of people vaccinated, but if a vaccine provides, 60% protection, you're going to still have some infection. So that plays a role too. But, we're lucky here in the United States, very lucky. We happen to be eligible and have access to like the modern marvel, these mRNA vaccines. So I think that's a part of it that obviously people don't think about, because if you're not a nerd like me and you don't read about like everything that's going on and know that different countries have access to different vaccines and they're using some that maybe are don't have that same high protection rate, that's different. But again, not dying. Number one.
Yeah, I think you make such an important point, and I think that it encapsulates all of those questions, right? Which is the fact that we're talking about different vaccines and different vaccine efficacy, right? And basically, like, what is the percentage of folks that get vaccine X that will still have what we're calling breakthrough infection, right? Yeah. So, like, if you have to your point, a vaccine that's either 60 or 75% effective, that's still awesome. That's still great. But that means that, out of 4 people who get that vaccine, 1 person is probably going to end up getting infected and being sick, right? As if they didn't get vaccinated. Doesn't mean that vaccines don't work. And I think what's frustrating for folks is we want a magic bullet. We want it to go away. We don't want anybody to be sick. We want everybody to get this vaccine and be 100% protected. And that's just not real. What you're doing is you're improving your chance of not getting infected when you get a vaccine. You're improving your chance of not dying. You're improving your chance of not getting long COVID if you get vaccinated. It's not zero. It's not 0%, right? Unfortunately, there is a chance that might happen. It doesn't mean that if somebody got sick that who got vaccinated, that vaccines don't work. Right. Because if you look at the graphs, and you can look at all of the CDC graphs, or you could go to Google and Google your community, and they have graphs for this, what the hospitalization rate is, what the death rate is for those folks that are not vaccinated compared to the ones that are vaccinated. And if you look at the ones that are vaccinated, it's not a flat line 0, but it's way different than the ones that have not been vaccinated.
Those graphs are like,
they're like this, right? They're like this. And so we totally understand everybody's frustration that it's not 100% effective, right? Everybody's upset about that. But the fact, and if you know somebody who's been sick or gotten infected, then it means nothing to you, right? Like for you, you're like, no, somebody got sick. This doesn't work. That's how it feels like to you. Mm-hmm. But we're saying that we're in a war. We're in a war with this infection, and you want to try to put on as much gear as you can to kind of protect yourself from this. And just like with any battle, you might win the battle, but there might be some casualties associated with it.
Right. And you might get one little, you might get like an arrow or,
right. You might get hurt. Yeah.
You might have a little harm done, but you're alive. Again,
but that's right. And so it's just managing all of these expectations, and with all of the rhetoric in the media and your own feelings. And we want you to talk to us, right? We want you to talk to your providers, whoever you think you trust, to really have a sit down conversation with you so that you understand all of these things that we're saying, because people are throwing around terms and it's confusing, and we're trying to see if we could just demystify it all for you. So hopefully this was a little bit enlightening and a little bit helpful, and we're open to feedback. So please give us some comments. If you've heard this and you want to be able to, you want us to address a couple of other things, we're open to doing that. So this was super fun, Ames.
Ask questions. We like that.
Yes, super we fun. Like questions. We love that. Super fun. Amazing.
So next time, martini.
We should bring martinis to the podcast.
You know, anyone who knows me, like, I mean, I know that, you know, you and I are friends from grad school and have, you know, definitely, you know, been in contact over the years, but I have about a martini every, say, 4 or 5 years, maybe. And it would be like a half.
Oh,
I know. Cheap date.
Martinis are strong.
Cheap date.
Yeah. Well, that's good. That's good. That's right.
You know, I could bring my my thimble of martini with me.
There you go. You can bring your thimble of martini. Just bring an olive. Just bring an olive.
Yeah.
And that'll
one soaked in the martini.
One that's soaked in the martini. That's right.
Sounds good.
I love that.
Oh my gosh. Well, this was fun.
Amazing. This was super fun. Go ahead and send it to me the same way